But what I'm going to do is show you how to use serverless cloud platforms to do just that. And in the second half of this talk, I'll actually be showing you how to build kind of a live application using one of these platforms to give you the tools and the techniques and the patterns to do this yourself. Now, as well as thinking, maybe, why would I want to build microservices without servers? You might also be thinking, this sounds kind of unnecessary, right? You think, I like my servers. I've got them set up just how I want them, and I can, log in over SSH to copy my WAR file over to deploy my application, right? Why would you want to take my servers away from me? Well, the reason is this, right? I think servers are killing your productivity. You might not realize it yet, but trust me, it's true. And I think by the end of this talk, you want to go back to your office, gather up all of those Ubuntu machines that you've got running your application, kind of set them on fire, and be free of the tyranny of looking after infrastructure forever. Right? I think servers are one of the worst things that's ever happened to software developers, and they're directly responsible for you being a worse engineer, writing less code, delivering worse products, generating less revenue for your company. But how is this possible, right? How is that little Ubuntu machine that sits in your kind of office warming your feet responsible for all of the evils that I've just talked about? Well, let me take you through a kind of story to explain why I feel so strongly that servers are killing your productivity. Imagine you wake up one day, right? You've had a brilliant idea for the next kind of billion-dollar unicorn startup, right? And you think, this is it, right? I'm going to be the next Mark Zuckerberg. I've got this fantastic idea. I've got the skills to turn it into a reality, and I've got some customers who want to try it out. So you spend your next couple of weekends furiously coding away in your spare time to try and build kind of the version 1 of your application, right? Your minimum viable product. And you finish it, so now you've got some code, and you've got some people who want to try it out. So you think, oh no, the next thing is to get a server, right? I've got my code, I put my code on the server, I can email the link out to some friends, people can use it, I can get feedback and go through this whole lean product development lifecycle that you hear about so much in Silicon Valley, and I'll be well on the way to building my next big startup. So you get your server, you put your code on the server, you email the link out to your friends, and then what happens the first weekends that your application's live? Well, your hard drive fails, right? So that server you borrowed, the hard drive has crashed, and rather than using your application, now users are staring at a blank screen. And it's a panic, right? I have to get a new hard drive, I have to install it, I have to reconfigure the entire environment, get everything back up and running. And while that happens, while that's going on, just as you finished fixing this hard drive issue, suddenly you get a new email that says there's a vulnerability in your Linux kernel, right? So there's a vulnerability in Ubuntu, and you have to patch the kernel to stop hackers getting in and stealing all of your valuable customer data. And to do that, you're going to have to take your application down again, right? No one's going to be able to use it. You're not going to be able to get any feedback. So just as you finish patching your kernel, right, suddenly you get an email telling you as well that your middleware is out of date. So now I need to update my middleware, and I think, well, my application is already down, so why don't I just quickly update the middleware, and then I don't have to do that later on. But when you update your middleware, right, your version of WebSphere or something like that, that requires you to upgrade libc, and then that clashes with some dependency that your database relies on. And suddenly, what should have taken you 5 minutes is 3 or 4 hours kind of untangling all these transitive dependencies to fix your middleware. It should have just taken 5 minutes. So you've patched your kernel, right, and I've upgraded my middleware, and maybe I've installed my new hard drive and got everything set up. And you think, okay, that's kind of in the past now. Now I can relax. I can go back to focus on writing my code and getting users to use my app. But when you bring your application back up, what you realize is that you haven't anticipated how much traffic is being generated by the front end. So now you need to upgrade your entire network infrastructure, right? And as well as that, your application is generating so much load that your server needs more memory and a bigger CPU. So and again, to be able to do this, you have to take your application down, you have to install all this new hardware, bring it back up, and users aren't going to be able to use your application during this time. And while that's going on, again, you're really focused suddenly on these hardware issues. You're not paying attention to your application logs, and what you realize is your database table has been corrupted, the index has been wiped out, now your server's running really, really slow, and users are having a terrible experience. And you kind of come to the conclusion at this point that your little server that you borrowed to run your minimum viable products, right, it's just overwhelmed, right? It can't cope with the amount of requests and resources going in. And what most people do in this scenario is they think, okay, if I've got one server that can't cope, I'll just get another server, right? Maybe I'll get 10 servers, and then I can run them in a cluster and worry about scaling and replication and fallover and all of that complicated little stuff. And suddenly you find yourself spending all of your time looking after these environments, right? Patching kernels, upgrading middleware, installing new hardware. And all of that is time that you're not spending on building your product, right? Writing code, listening to customers, getting the next version out there. And I think as software developers, it often feels like we're being held hostage by our servers, right? You want to spend all your time working on your app, and you spend all your time managing these environments. Now, you might think, hold on, James, right? Wasn't the cloud supposed to fix this? I'm always been told that I have to put my applications in the cloud, build cloud-native architectures, use everything as a service, and all of these kind of infrastructure challenges go away. And we're told about companies like Netflix and Etsy and Uber and Amazon who have had great success building their companies using kind of public cloud resources. Right? Netflix doesn't own any data centers anywhere in the world today. They're purely a public cloud company. And we're often sold this utopian vision, right? That cloud computing allows you to treat computing resource like a utility, right? Like electricity or water or gas. That you can turn on or off on demand as you require it. But for many of us who are kind of aggressive early adopters of cloud systems, right, what we think of as infrastructure as a service, what the cloud meant to us was renting virtual machines in someone else's data center. And although you didn't have to physically buy the server and plug it in and turn it on, you were still going to be responsible for everything from the kind of operating system up, right? I still had to patch those kernels and upgrade my middleware. And this is a bit like, if this is supposed to be a utility model for computing, I think this is a bit like, building a house, right, wanting to get connected to the electricity grid. And when you ring up the power company to get connected, they say, we can't just connect you, but what we can do is we can bring around all the components to build a power substation, right? And we'll assemble it for you so you don't have to do that, but you're going to have to maintain it once it's up and running. It'll be running 24 hours a day, whether you use it or not. And not only that, if you need to predict how much electricity you need in 12 months' time so we can make sure the substation's big enough. And that's not how I get electricity at home, right? I just get connected to the grid. So it seems, I think, there was no escape from these servers, right? Whether you're running your own infrastructure or whether you're using kind of early cloud systems, you still had all of these servers to maintain. And it was not only, I think, time that you waste, it's money. So there was a survey by Google in July 2013 looking at the utilization rates for some of their big clusters, right? Clusters with 20,000 machines in. And they found the average utilization was just 20 to 40%. That meant that 60 to 80% of the time, your servers, your applications are sat there idle waiting for requests to come in. And if you rent virtual machines by the hour in some public cloud provider, right, you probably have similar utilization rates, which means you're spending money and getting no return. And again, if this is supposed to be a utility model of computing, this is like having a water tap in your house that you have running 24 hours a day just in case you need to go and get a glass of water in the middle of the night. And that's ridiculous, right? We don't do that at home for utilities. So what can we do, right? It seems like we're stuck in a bit of an impossible situation. But I think the first step to recovery is kind of admitting that we have a problem, right? And I think the problem software developers have today is managing all of these server environments. But what can we do, right? It seems that obviously, don't I need some servers to run my code and I have to manage those environments? But then anytime I go into these servers, it kills my productivity. And then I think something quite exciting happened at the end of 2014, which is that Amazon launched a new service to the cloud called Lambda. This is Werner Vogels, their CTO, introducing it on stage at one of the big conferences. And Lambda was supposed to be this next generation cloud computing service that really allowed you to treat kind of computing infrastructure like a utility. But you wouldn't necessarily get that if you read the press release, right? It sounded like pretty much any other press release out there. It said, Lambda runs code in response to events, manages all your resources, allows developers to build event-driven applications. And again, that doesn't really sound that revolutionary. But Lambda was different, and it was different for a couple of reasons. The first was that it shrank the unit of deployment. So rather than deploying your application as a big VM with all your services and database built in, or even as a monolithic deployment package, you could literally just deploy the microservices, those functions that you want to run in response to external events, right? So when some API request comes in, run my code and get rid of it. And the server, the platform, Lambda and systems like it, will spin up an instance of your microservice on demand to process one request and then get rid of it afterwards. So now I don't even have to think about servers, right? Or even doing big configuration. everything's handled by the platform itself. So what happens if you've got one of your microservices on Lambda or a system like it, right? Processing some request, and another request comes in parallel. Well, with Lambda and systems like it, all that happens is the platform on demand spins up another instance to process that request. So you can kind of scale to cope with almost infinite load without really having to think about it. I don't have to think, right, how many requests can this server with this much hardware have, cope with per minute? And as well as scaling up, right, to cope with lots of traffic, it also scales down because, as I said, you're only running code when you're actually processing requests. So most of the time, if your application is idle, waiting for logs to be generated or a database to be updated, none of your code is actually running, right? Which means that, suddenly I don't have any code that I'm not using. And this is the scaling part of it is really important when we think about the kind of pricing model, because Lambda, like all kind of cloud systems these days, is pay as you go, right? You only pay for the resources that you use, but with Lambda, you're only actually having to pay for the resource that you use, and you're only using resource when you're processing requests from some external system. So that means that most of the time, if your application is not doing anything, now you don't actually have to pay for it. And this can lead to some kind of extreme cost savings. So there was a Business Insider article last year, I think, talking about Lambda and some of the customers, and they talked to a cybersecurity firm who had an application that was processing logs that were being generated by customers, right? And it was a couple of VMs that was on, EC2 or something. And most of the time, their application was idle because the log traffic would come in, they'd process them, and there'd be nothing to do. So they heard about this Lambda thing, and they decided to kind of rewrite it as a set of kind of stateless microservices. And what they found is at the end of the month, their monthly bill had dropped by 80%. So this was thousands of dollars a month, down just a few hundred, because now they're only having to pay for resource when they were actually using it to process logs. They didn't have these VMs idle waiting for traffic to come in. Now, some of you might think, right, isn't this just platform as a service? Right? I use Elastic Beanstalk, I use Heroku, I use Cloud Foundry. I don't really have to worry about servers and setting them up and SSHing in. And also, I can kind of scale elastically in response to demand. And it's a good question, right? There's some similarities with what I think of as this new serverless thing and platform as a service, but there's some key differences as well. And I think the best answer to this question comes from Adrian Cockcroft, who is CTO of Netflix, obviously a very visionary person in the cloud space. And he was having this debate on Twitter about, is serverless really different than PaaS? Is it really that new? And what he said was, if your PaaS can start an instance of your service in 20 milliseconds, run it for half a second, and then get rid of it, just to process a single request, then you can call it serverless. Otherwise, it's not, right? It's this kind of more traditional model of cloud computing. And I think that kind of spells out for me why it's so different. So Lambda was kind of launched at the end of 2014, which is this blue line here, and it's been steadily kind of growing in popularity with developers ever since. But then I think something really interesting happened in 2016, right, this little red line, is that this whole kind of term serverless took off to describe the ecosystem and the frameworks and the architectural patterns for building applications in this way, as developers realized some of the benefits it could bring. And I think the real reason that serverless has got so big this year particularly is that all of the other providers have launched kind of competing services, right? So originally it was just Lambda on AWS. Now you have OpenWhisk on IBM's Cloud Bluemix. Microsoft Azure has one called Azure Functions. There's Google Cloud Functions. There's WebTask. There's INO, who are kind of smaller providers. So whoever you use for your cloud system, right? Whether it's Amazon or Microsoft or IBM, they probably now have one of these kind of service solutions for you to play with. So it's not purely just an Amazon thing anymore. Now, before I go any further, I want to drop in a little spoiler, right? I don't want to mislead anyone at all. And the spoiler is that there's still servers, right? When you're using one of these serverless platforms or however you're running your code in the cloud, it's going to be running on some virtualized Linux instance in some data center in probably somewhere like Virginia. But the term serverless really refers to the developer's point of view or the developer experience, because from the developer's point of view, all I have to do is worry about focusing on my code, and the platform handles everything else, right? Your code might as well be running on an actual cloud in the sky for all of the interaction that you have with a kind of underlying environment. So, all right, enough talking, right? Bring on the code, and I want to now show you how to use one of these platforms to build a kind of sample application, right? And give you the tools and the techniques to be able to go and do this yourself. Now, obviously, I need an idea. I need something to build. And a couple of weekends ago, I woke up and I had what I thought is a kind of a good idea. And my idea is about the weather, right? Something you might not know about people from the UK, because I'm from the UK, is that we're obsessed by the weather, right? We love to talk about it with our friends. We love to worry about whether it's going to affect our holiday, and we kind of religiously check the forecast every day. Mostly, I think, because the weather in the UK is terrible and it just rains a lot of the time. And as well as being a British person who worries about the weather, I'm a software developer. And I know one of the big trends this year has been bots, right? Everyone seems to be building bots for everything. Facebook has the whole platform for messenger bots. Microsoft has this big framework. So my genius idea is, could I build a weather bot, right? Could I build a bot that helps me when I'm worrying about the weather to give me forecasts on demand, maybe warn me if it's going to be raining in the morning? And as I said, as a British software developer who worries about the weather, I also love to use Slack. It's my favorite communication tool at work. And if you haven't played around with building bots of Slack, it's a really nice platform to use because it's got all this kind of webhook integration you can kind of play around with. So I thought I'd try kind of my version 1 of my weatherbot example for the Slack platform. Right, so we've got my idea now. I'm going to build weatherbot for Slack. And you can see a kind of initial implementation there. The next thing I need a serverless platform to play with. And today I'm going to be using IBM's OpenWhisk, which we announced back in February and is available on our cloud Bluemix. And it said you can go and sign for a free account for no charge and kind of completely play around with it. It's still in beta, so there is literally no charge for using it at the moment, so it's a great time to go and play around with it. But the techniques and the architectures and the kind of patterns that I'm showing you today are applicable for any serverless platform. So if you use AWS and want to use Lambda, use Bluemix, you want to use OpenWhisk or Google Cloud Functions, it's the same kind of patterns across all platforms. But if you're evaluating your choice of kind of serverless platform, there's a couple of good reasons to take a look, I think, at OpenWhisk. And the first is that it's open source, right? So when we announced the platform back in February, we also put all of the code up on GitHub. So you can go to github.com/OpenWhisk, pull down the entire project and kind of play around with it locally if that's what you're interested in. It uses very standardized kind of cloud components that are open source. It uses Kafka, it's got Docker, it's got console in there. There's no kind of secret IBM source. But a great thing is that the team is continuing to develop code in the open. So if you can go and look at the milestones, see what they're working on, you can raise issues if you've got bug requests, or you can submit pull requests, right? Get your code back into the project. And we're trying to build a really like kind of a vibrant open source community around it. Another good thing I think about OpenWhisk is its runtime support. So it supports all of the major runtimes that are kind of common across all of the service providers. So all the service providers mostly do 1 or 2 versions of Node, Java, we support Java 8, and Python, some version of Python, right? So whether you're using Google or Amazon or OpenWhisk, they're kind of supported out of the box. An interesting choice of runtime support in OpenWhisk is Swift. So Swift is the language that was developed by Apple a couple of years ago for building native iOS applications, and they've open sourced and is becoming kind of popular as a language in its own right. And the reason that we added Swift support is that we think that serverless is a great use case for mobile, right? Building mobile services or mobile backends. And that means that those developers who are comfortable building their native app in Swift can build their backend in the same language. But by far, I think the best feature about kind of OpenWhisk in terms of runtime support is that it's extensible. So if you want to build your microservices in Kotlin or Scala or Haskell, right, something that's not supported out of the box, anything that you can wrap in a super lightweight Docker container, you can actually push that image directly into the platform and have executed on demand, right? So now, you've got a lot more choice about what you build your serverless functions in. I don't think that's supported in many of the platforms at the moment. So we've got our idea, right? I'm going to try out this weatherbot thing, and we've got our platform. We're going to try OpenWhisk. The next thing I need is some code, right? Code that might look a little bit like this. And I'm going to be using Node.js just in my examples today because my services are small. I'm particularly comfortable with that language, but I think most people can understand how to parse a bit of JavaScript. But as I said, you could use any of the runtimes that I just talked about to build your microservices in. Now the question is, right, when you've built some microservice code, you want to push it up to one of these service platforms, how does the platform know what to do with it, right? As I said, you don't have to bundle it in some big monolithic deployment package or do loads of configuration. So how does the platform know how to execute it when a request comes in? Well, for every runtime that you choose to use, there's a tiny interface that you have to add to your code, right? So you add this tiny interface, and that's going to act as the entry point. So when a request comes in, the platform on demand will kind of dynamically evaluate your code and call this interface to get give you the data, and then you can return some data to be kind of serialized back. So for example, right, for JavaScript, imagine this myservice.js is like thousands of lines long, has hundreds of functions, it has third-party NPM modules, and all you'd have to do to make it compatible for the platform is make sure you have a global function called main, which takes an object and returns an object, and that's all you have to do, right? So all you have to do is add this super lightweight interface. Let's show you Java as well. Right, again, imagine this is your big Java class file. All you have to do to make a class file kind of as suitable as one of these serverless functions is just have a public static main that takes a JSON object and returns a JSON object. And then you can do whatever else you want in the in that bit of the code. So once you finish your code, right, you push them into OpenWhisk. OpenWhisk creates what's called an action. Right? An action is just the name that we use in OpenWhisk for your kind of dormant microservice that's sat there waiting to be executed when requests come in. So let's show you doing this now, right? Let's take some kind of sample code from my laptop, deploy it to OpenWhisk, and show you kind of how we can use it really quickly to build up this weatherbot idea. So if I do that, and then mirror my screen, I have some water. So let's bring up. So as I said, OpenWhisk is completely open source, right? So you can go to GitHub, you can pull down the project as a VM and deploy it yourself to any kind of infrastructure provider. But I think the easiest way for many of us to get started is if you go and sign up for a free account on Bluemix, which is IBM's cloud, you get a fully provisioned serverless platform to play with. And that's the kind of one I'm going to be using today because I think it's just easiest to get started with. Again, you've got like a browser-based code editor if you want to kind of just develop in the cloud directly. There's a monitoring dashboard and all that kind of stuff when your serverless functions are live. But I like to develop on the command line using Vim and then push my services up to the cloud. So to do this, we need some way to interact with the platform, right? And the way we do this is we have a little command line utility that we install locally, and you authenticate against the endpoint, and then we can kind of push our code locally up to the cloud. So I've obviously already done this. So you can see if I go back to my terminal, yeah, there we go. So I have this little command, whisk. I can show you that basically allows me to do everything with the platform, right? We're going to use this to kind of deploy some sample microservices. So for example, let me walk you through the Hello World example. So I think this is the world's smallest but most useless microservice, right? So you can see it's just a greeting service that gets executed. It has the interface that OpenWhisk expects. So it's got a function called main, takes some object, uses a username, and then returns you a greeting with your name in. So once I've finished my hello name greeting service, I can deploy this straight to the cloud and have it running as a kind of scalable microservice on demand because it's obviously it's kind of it's really amazing. So the way we would do this is, again, we use the command line and we type whisk action create. We give it a name. And I give it the path to the file. I can check that it's been deployed. So there we go. We can see hello name is there. So now I can invoke it. Passing in my parameter, user James. And hopefully you should see in the response, right, there's a result message. That's the response of my JavaScript being executed in the cloud, right? It's passing me back my greeting. I haven't had to set up Node.js. I haven't had to worry about any servers. I could call this 1,000 times in parallel, and the platform would just automatically handle it. So let's have a look at Java as well, because I have the same microservice written in Java. So again, you can see, right, so I've got my public static main, looking for an argument for the JSON object, and then returning me an object which is serialized back as my response. So for Java, there's a couple more things you have to do. You have to compile your class file. I have to add it to a jar file, because that's what you deploy. And then I can create a new action, whisk action create, hello Java, and give it the path to the jar. And then I should be able to invoke it, right? So invoke hello Java. What parameter did it? Wanted a name, so we'll just get a James. Right, and you should see, it takes a little bit longer, but again, there's my greeting that comes from evaluating that Java code dynamically in the cloud, right? Haven't had to to set up a JVM or worry about messing around with class paths anywhere, right? It's a really quick way to get started. So that's the hello world, what I think was the hello world example. But what about actually using it to build this weatherbot thing that I had my brilliant idea for? Well, I think weatherbot has to do a few things. I think it has to be able to be triggered by an address, and from that address it has to go and get a location to find the forecast for. It has to be able to do forecasts for a location, so what's the weather going to be like in the 24 hours, and then it has to integrate with Slack, right? It has to be able to post messages into Slack whenever it gets triggered. So I've actually built some of these services so I didn't have to type everything live on stage. So let's start with my first kind of tiny microservice like this. This is called a location to lat long. And what it does is it uses a third-party geocoding API. So when it's triggered with an address, which comes in here, it calls this API, looks up for the closest address match using an asynchronous HTTP request using a promise, and then returns me the location, the lat long down below if that succeeds. So I can deploy this like that, and I can say whisk action invoke location to lat long. So now we need to pass in an address. So let's try Kyiv, see if it can tell us where we are. So hopefully, there you go, right? That should be allegedly the latitude and longitude for the center of Kyiv. So that was pretty easy, right? That's my first service that I'm using to build weatherbot already up and running. Let's have a look at my next one. So I have forecasts from lat long. So again, kind of similar thing where calls a third-party API. So this is a weather API that I've already signed up for some credentials with, passing in the latitude and longitude as parameter, and then we'll just pass back the kind of forecast for my service if it's made a match. So let's deploy that. Call it forecast from lat long. And let's invoke it. Action invoke. Forecast from lat long. Now this takes a couple of extra parameters, right? This takes a username, which I have stored in environment credentials. And it takes a password, which I've also stored in environment. And then it obviously takes latitude, which was about 50, and a longitude, which was about 30. And hopefully, if that works, right, there we go, right? That is allegedly what the forecast is going to be like in Kyiv. Mostly cloudy, low overnight in the low 30s, which I think sounds like about right. Now, if you're using serverless functions to call third-party APIs like this, you don't want to have to pass in a username and password with every single request. You also don't want to store that in the code because that's not a good idea either. So something you can do in OpenWhisk is use the platform to manage those credentials for you by binding what they call default parameters to your package. So I want to be able to call this service without having to pass in that username and password every time. So we're going to update it to automatically handle those. So I can say whisk action update. You give it the name of your service, and then you literally give it the parameters that you want the platform to store. So I want it to store my username and a password. So, we go forward. Cool. So now if I go back to my invocation, I should be able to get rid of the username and password from the parameters. So now I'm not passing in the username and password, and hopefully it should return as the same data. Cool, right? Now my kind of platform's handling that, and I don't have to kind of mess around. The next thing I want to do, right, I've got my two services to do locations and forecasts, is I want to think about integrating with Slack, right? So I have, if I go back to my menu, have this weather channel at work, and all we do is worry about the weather and talk about my friends and that kind of stuff. And I want to be able to post that forecast that came back from that other microservices into there as a message from a bot. And to do this, we're going to use webhook integration. So Slack has what's called incoming webhooks, where you can, the platform will give you a URL, you post some JSON to that URL, and it'll turn up in the channel as a kind of bot message. And so I've started to create one for my weather bot. You can see down the bottom here. So it's going to post it into weather. Here's the URL. If I go and save that. So now I need a service that when it's triggered with that, some text will automatically make that HTTP request to post it into the channel. And I could go and I could write this myself, as we saw, right, using some third-party NPM module. But OpenWhisk actually comes built in with lots of packages for integrating with third-party systems. And one of the ones it comes built in with is a package for integrating with Slack. So I don't have to write some code to be able to call this webhook. I can just invoke one of these packages that comes built in. So if I go back to my terminal now, and I say whisk package list, whisk.system, it will show me all of the kind of inbuilt integrations that come with the open source projects. And you can see there's one down here for Slack. So I can get the summary and see what's actually inside it. And it shows me that we already have an action deployed in the system for integrating with these services. So rather than having to write that myself, I can just invoke it with some parameters. So I can say invoke this action. Now I know that it needs a URL, right? It needs my webhook because it doesn't know that. And it needs a channel, and it needs some text. Hello. And so hopefully you should see a message pop up in Slack. Does it come? Yeah, there we go, right? There's my message from my little bot, right? So rather than having to write this service yourself, you can use some of those default integrations. Now I wanted to change like the emoji and the title. So I've actually copied that default package into my workspace and bound some default parameters. So all I have to do is call it with my text each time. So I can see if I go whisk action list, you can see that I already have an action called webhook, and all I have to do is call this with some text. Hello. And that's the kind of icon that I want to use. So I've got my 3 different services that I'm using to build WeatherBot, right? Something to handle addresses, something for location, something to be able to talk to Slack. And what I want to do is I want to kind of combine them together. So when an address comes in, each service is called in order, and the result gets posted into the channel. And one of the ways you can do this with OpenWhisk is using what they call sequences. So what sequences are is a way to define new actions, new kind of services, serverless functions, that literally are just composed of other functions already kind of running in the platform. So rather than having to do that myself, I'm going to define a new sequence which says call this service, call this service, call this service, passing the output from one to the input as another. And I think of this a bit like Unix pipes, right? Where you write commands with the pipe command to execute them in sequence, passing the output from one to the other. So let's do this now to join my 3 sequences together. So I can say whisk action create, give it a name, location, forecast. I tell it it's a sequence, right? And all you have to do is give it the other actions that you want to call. So we want to call this one. And I want to call this one. Select it. And then I want to call my webhook, right? So hopefully, if this works, I should now have a new action that I can invoke with the input to the first parameter in the sequence, location, forecast. And I give it an address because that's the input to the first action in the sequence. I'll call Kyiv. And hopefully, if this works, we should get in the channel, there we go, the forecast that we saw from my second microservice appearing in the channel. So I've been able to define a completely new serverless function without writing any code by just joining existing ones together. And I think this is really kind of powerful feature of the platform. So let me jump back to Keynote for a little bit now. I'll do that. Cool, okay. So that's how obviously you can take some sample kind of microservices or sample functions and deploy them to the cloud as these kind of scalable services using a kind of command line utility. But once you've got them deployed on the platform, right, your actions are sat there waiting, how can you integrate them with your application, right? How can you invoke them on demand? Well, the first way you can do this is using the platform API. So OpenWhisk has a really, really comprehensive REST API for doing everything with the platform, from deploying new services to invoking them to getting the results out. And when I was using the Whisk utility on the command line, all that utility does is send these REST API commands under the cover. So for example, every action that you deploy has its own HTTP endpoint that you can send an authenticated HTTP post request to be able to invoke it and get the result out. Now, obviously, this presents a challenge if you want to build public APIs or public endpoints for with your serverless functions, because you can't embed your developer credentials in some client-side web app, right, without exposing it to the world. So what everyone does in this, the kind of pattern for doing this, is to use an API gateway. So an API gateway is a third-party cloud service that allows you to define public endpoints that can then proxy private APIs in the back end. All the big cloud providers have this kind of service. So Amazon has one called API Gateway. We have one called API Connect. Google's just bought a company called Apogee, which does this. And using those services, the pattern is that you use an API gateway to define your public endpoints, and then you use those to call the kind of private APIs to kind of trigger your service functions on demand. So that's obviously how you can integrate directly calling your microservices into your application, right? Anything that you can send an API request from, you can obviously invoke your service on demand. But what about kind of asynchronous processing, right? You know, having your services listening to messages coming on a queue, or database being updated, or with some logs being generated, kind of, as I said, asynchronous processing. Well, in OpenWhisk, we handle this through something we call triggers, and you can set up triggers in the system that actually binds these external event sources to fire whenever those events occur, right? So whenever your database is updated or a message comes on a queue, this trigger that you've defined in OpenWhisk fires automatically. And then in OpenWhisk, you can bind your triggers to your actions using a rule. And a rule says when your trigger fires, because your database updated, pass that data through to your action, and you can use this to have the platform invoke your microservices on demand rather than you having to do it directly. So let me kind of go back to my terminal, right, and we'll actually look at using both these approaches to kind of finish off WeatherBot a little bit. So the next thing I'd like to do for WeatherBot is, come in. The next thing I'd like to do for WeatherBot, right, is I want to be able to request forecasts through the channel. So I want to be able to type weather London, and I want to have WeatherBot automatically responds. And again, the way we're going to do this is using Slack's webhook integration. So Slack also has what's called outgoing webhooks. And what these allow you to do is register a URL to be called whenever someone types a particular message in a channel. So I've started to set one up already. So whenever someone says the trigger word weather in the channel weather, it's going to post that data to some URL that I've got down the bottom. And I've used an API gateway service to set up a public endpoint for my kind of serverless function that we created before. So if I go and click save, once that's done, if I go back to my channel and press weather London, there we go, right? Then my webhook fires in Slack, which calls my API gateway, which calls my sequence, which executes all my services and gives me the result back in, you know, a couple of 100 milliseconds or something. So now I've got a way in my channel to be able to talk to my WeatherBot and get forecasts for anywhere I am in the world. So that's the kind of first way you can call your functions. What about some of this asynchronous processing? Well, one of the things I like to do with WeatherBot is I'd like it to warn me, maybe in the morning, what the weather's going to be like for today, so that I can understand whether I need to take an umbrella to work. And one of the ways we can do this, as I said, is using those triggers, right? Triggers allow you to connect to external event systems into OpenWhisk and have them fire automatically. And one of the triggers that comes built in with OpenWhisk is, one of the packages that comes built in is for an alarm trigger. An alarm trigger allows you to say, according to this schedule, right, automatically fire the trigger. So you could set it up to say, you know, call my trigger every morning at 8 a.m., every day, every week, every hour. And I want to set one of these up to invoke WeatherBot on demand in the morning at 8 a.m. Now, if I go back to my, browser, I can actually see in the documentation, right, about using these trigger feeds, there's an example of using what they call the alarm package to be able to set up a trigger that fires according to a regular schedule. Now, if I set it up to fire at 8 a.m. every morning, right, you're not going to see that it actually works. So I'm going to use this example of using a trigger that is created and then fires every 8 seconds. So hopefully I should kind of verify it works. So you can see it's using what they call a feed, which connects it to that default alarm package. So if I copy this into my terminal, you have to give it the data, let's fire it with Kyiv, that you want it to fire with. So I say address. And then what I need to do is I need to create my rule, which says my rule, bind every 8 seconds to location forecast. And hopefully, what should happen now is that every 8 seconds, this trigger, this alarm is being fired, which means that my kind of microservice should be automatically fired on demand. So if I go back to Slack, There we go, right? You can see every 8 seconds, suddenly I've got this message appearing. And you can use triggers to automatically connect all kinds of external systems into Slack. Now let me just go and disable that before I continue because it will drive us mad. Rule disable my rule. All right, so turn it off. I'll do that. Cool, okay. So if you've been kind of following what I've been showing you over the past kind of 40 minutes, hopefully you're kind of starting to see why I think serverless is so interesting, right? You can really, really easily get microservices, small bits of code into the cloud, run them as these scalable functions on demand without having to worry about or set up any servers. And maybe, you're so excited you want to go back to work on Monday. You want to tell your boss about this thing you heard at this conference and gather up all of those servers, set them on fire, be free of the tyranny of looking after infrastructure forever. All right, but before you do that, right, before you set fire to your servers, I want to introduce, I think, some of the challenges of building applications using these platforms. Because like all, architectural choices, it comes with constraints, it comes with trade-offs, and it comes with challenges. And I want to kind of introduce some of those to you so that I can hopefully give you some solutions as well. Now, the first challenge around serverless is the compute limits, right? Serverless platforms really limit the kind of computational resources that you have available to you. And they do this because they're very opinionated about the kind of application architecture that it expects to run, right? Please don't think that I'm telling you to go and take your legacy COBOL app that runs payroll and try and rewrite it to use OpenWhisk, right? It's not designed for that kind of application. It's for modern, what we think of as cloud-native apps. And one of the ways that they enforce this architectural, kind of opinionated architecture onto you is by limiting your computational resources. So these are some of the kind of the limits that you have on OpenWhisk for different properties. It's things like timeouts, right? So your microservice has to complete execution of a request in a maximum of 5 minutes. If it doesn't, the platform just kills it off, right? So it's not designed to run in super long batch jobs that run for hours. Again, memory is the same thing. You can change the amount of memory your microservice has, but up to a maximum of 0.5 GB, I think, on OpenWhisk. So if you're Bitcoin mining and you need loads of RAM, it's not going to be suitable. And these kind of the same limits pretty much for any provider. But the reason they do this, I think, is that constraints are liberating. Often when you're following a set of architectural constraints, you get kind of unintended benefits for free. And it's definitely true with serverless. So it's things like your microservices have to be stateful. They have to be stateless, right? They can't use application state to store variables between invocations because they just don't exist, right? They get killed off. You have to push all of your state out to some third-party service. But the benefit of following this constraint that it imposes on you is that scaling is easy because scaling is now the platform's responsibility, right? I can spin up as many instances as I need in parallel and execute them, and I don't have to worry about kind of replicating application state and all that kind of stuff. Monitoring, debugging, and testing are also quite challenging if people are kind of new to serverless development. And the reason is that a lot of, I think, the techniques that we have, especially for monitoring and debugging, right, are reliant on you having physical access to the server, right? Being able to SSH in and, attach a debugger to some process, or maybe you're going to grep through the logs to find out what's going on, or trace through the system calls that's coming out in your kernel. And you just can't do that with serverless, right? I have no way to access the underlying environment, so I've got no way to use any of those tools and techniques. So one of the things I think you can do to help if you're building these serverless functions is make sure you really have comprehensive logs being generated, which can, after the fact, allow you to kind of diagnose problems kind of an old school way, because you still get access to standard out and standard error. So you need to make sure up front that you're generating comprehensive logs that you can drain to Elasticsearch or something and then use to diagnose problems afterwards. Testing is also kind of, it's easy in that unit testing your serverless functions, I think, is pretty easy. You can knock up a quick test harness. They're kind of fairly independent and they have a defined entry point. But how do you system test these things, right? How do you have dozens of different services running in parallel on someone else's infrastructure and kind of flesh out bugs that come from things like that? OpenWhisk can help a little bit. Because it is open source, you can spin up the whole platform in a VM. You can get a slightly more realistic system test environment by running it yourself locally, but it's not perfect, and it's one of the challenges of developing serverless apps. Complexity is another big challenge. I think if you are, you're sat in the audience listening, and you are a Java developer who develops one monolithic Java app that you deploy with a WAR file, that you deploy, come back, that you deploy as a WAR file to your one server. The idea, am I standing on the cable? I think I jumped around too much. There we go, let's come back. So if you're this Java developer who thinks about, I can just tell you, right? If you're a Java developer who is used to developing a single monolithic app, the idea of having all these dozens of services running in parallel, and how do you roll out updates and how do you roll it back if things go wrong, right? It probably fills you with dread, right? It seems like a huge increase in complexity. And that's definitely true, right? It's one of the downsides, I think, of microservices-based development. And one of the ways you can manage this is using frameworks. That's going to show a framework in a minute. Frameworks, there's some really, really big ones for serverless. This is one called the serverless framework. It can have all your configuration as code. It can deploy your services automatically. So if you're thinking about building these kind of apps, definitely check out some of the popular frameworks to help with that. So I said at the start of this talk, right, that servers are killing your productivity. And hopefully now you agree with me, right? You think all of that time you spend patching kernels, upgrading middleware, worrying about kind of infrastructure issues is time that you're not spending on your product, right? Building your wonderful startup idea, making your business better. And I think that developers are being held hostage or have been held hostage for too long by their infrastructure. And for me, I often felt like the dog in this cartoon, right? My infrastructure, it was always on fire, right? You know, my servers were crashing, my kernels were panicking, my disk spaces were overflowing. But I just kind of convinced myself that this was fine, right? This was the best way to develop applications, and there's nothing I could really do about this anyway, right? You have code, you need some servers to run it on. But then this serverless thing came out, right? It had all of these benefits, right? I didn't have to worry about environments anymore. It could dramatically reduce my kind of bills. Scaling became easy, and it was just a much, much quicker way to develop kind of cloud-native applications. And suddenly, I didn't have to worry about these server things anymore. So I want to kind of encourage everyone, right? If you're building kind of modern applications for the cloud, think about embracing the serverless revolution, right? Burn your servers, deprovision your virtual machines, be free of the tyranny of looking after infrastructure forever. But most importantly, right, upgrade your productivity. Stop wasting your time managing these environments. Get back to writing code. So thank you very much for listening. If you want any of the resources from this talk, right, if you want the code, the transcript, the videos, if you go to the bit.ly link at the top, burn your servers, you go to a GitHub repository with everything in that you can check out, so you can kind of run through and kind of have a play yourself. If you're using OpenWhisk and you want help, we've got a Slack channel, obviously. We answer questions on Stack Overflow, or if you want a more personal introduction, come and find me on Twitter or kind of tweet OpenWhisk and we can kind of get you started. So yeah, thank you very much. I think I'm almost out of time.